This is part 2 of the video for integrals resulting in inverse trigonometric functions. We're going to cover 2 intermediate examples. So example 3 asks us to integrate x cubed over the square root of 1 minus x to the 8th dx. And when you think back to when you would do u substitutions, when you would kind of see this difference in powers of the same variable, you might think, oh, there might be a good u sub here, but 8 and 3 are pretty different. However, it also has the form for our arc sine. And once we figure out what u is, the x cubed is going to help us out tremendously. So for a squared being 1, we have a equal to 1. And then if we let u squared be x to the 8th, then u would be x to the 4th. And that's nice because then du becomes 4x cubed dx. And we have an x cubed dx in the integrand, so I like it. I'm very meticulous about my U subs, so I always write what I have in terms of, here in this case, x cubed dx, and what does that mean for me when I'm writing my du? What constants, if any, should be with du? Okay, so once I replace everything, I get 1/4 times the integral of 1 over the square root of the quantity 1 squared minus u squared with respect to u. And this is a very straightforward substitution. We're going to get arc sine of u over a, where a is just 1. Don't forget about your 1/4. And I'm going to go ahead and put this back to x. U was x to the 4th. So I'm going to get 1/4 arc sine x to the 4th plus c, or you could write that with arc sin as well. In our second and last example, we're asked to integrate 3x plus 6 over x squared plus 1 with respect to x. And this does have the feeling of arctan because we have the sum of squares where one square is a variable in the denominator. But on top, we have 3x plus 6. And, if it was just like 3x, that might be nice because I could see a u sub there with x squared, but I have a sum. It's rational polynomial, so I don't really know what to do here. I want it to look like this, but right now, the numerator is really throwing me. So what you can do, because your friend, the integral, is a linear operator, you could split it over sums, meaning I can take this as 3x over x squared plus 1, which I said would be nice. And behold, it is, and we have it. And I can add that to the integral of a constant over x squared plus 1, which of course I can do that. That's like basic arctan. So we'll have to work these individually because they're 2 separate methods. On the left, we're going to have a really straightforward u sub, and on the right, we're going to have our inverse trig formula. So here on the left side, we're going to let u equal the denominator, x squared plus 1, so that we get du equaling 2x dx. And I have a 3x dx. So if I'm clever, I can multiply both sides by 3/2. And I'll get 3/2 du equaling 3x dx. And again, I like that because now when I go to say what du is, I can already know what my constant that goes with it. So I'll have 3/2 times the integral of 1 over u du. And this is your favorite integral, the natural log. So 3/2 times the natural log of the absolute value of u. Don't worry, I haven't forgotten about our integration constant, our constant of integration. I'm just going to do it at the end. So I'm going to put it back to x. Of course, we're taking absolute value here, but we can see that x squared plus 1 is always above the x-axis. So the absolute values, you don't need it, but I already wrote it. So we're keeping it. All right. The other piece, 6 over x squared plus 1, that's your friend. That's arctan. And the only thing to worry about is keeping that 6. But again, it's just a constant in there. So this should just be 6 times arctan. And to be extra sure, we're going to say, hey, look, a squared is 1, a is 1. U is x, so du is dx. Nothing to see here, folks. So this should be equal to 6 over 1 over a, 1 over 1, times arctan of u over a, which is x over 1. And I'll clean that up. Just get 6 arctan x plus c. And don't forget, you're adding these two individual pieces together, plus c. That's it. You did it.